Right, so 5 years ago, I decided one weekend to try to once again to get my children into science and technology. And I have failed time and time again. I've got 5 kids, and possibly because I'm trying so hard to get them excited about science and technology, they're not at all. But this weekend, we got a Lego Mindstorms kit into the office. My day job is I'm the editor of Wired, and we got this in for review, and I thought I'll bring it home and show the kids. And then we got this radio control airplane in at the office, and I was like, best weekend ever. Saturday we're going to build a robot. Sunday we're going to fly a plane in the park. This will be the day. This will be the weekend that the kids get into science and technology. So this is Erin, and she's one of my daughters, and this is us starting on Lego robotics. And we spent the morning building a tribot, this little 3-wheeled thing. And you put it together, and they like Legos, they were willing to do it. And then we program it. And this is Daniel, and this is when we're getting it started. And they just couldn't believe it. It's like, that's it? It's this thing just bounces off the walls and goes backwards? I mean, we've seen Transformers. We know what robots are supposed to do. Where are the lasers? Why is this not transforming into a truck and then destroying the city? So Hollywood and CG have ruined robotics for children, and I'll never forgive them for that. So I was a little disappointed, but I said, there's always Sunday. So Sunday we'll fly the plane. And so it was like a foam plane like this, and Sunday looked like that. And the kids were, once again, confirmed all their suspicions that science and technology is invariably disappointing, that their dad is hopeless. And so we went home. I had to bribe them with ice cream. I was kind of annoyed, frankly. I was annoyed that they were so kind of hard to excite. And so I decided to go for a run. I was thinking about the day, the weekend, and how badly it had gone wrong. And I was thinking, God, Lego robots, airplanes, sensors, how could we not have made something better here? And I thought, that, and plus I suck as a pilot, I'll bet that Lego could have flown the plane better than me. And I thought, maybe the Lego could have flown the plane better than me. So I came home, and I said, guys, in that Lego kit are sensors, gyroscopes, accelerometers, compass, magnetometers. There's connections to Bluetooth, which you can connect GPS. It's got processor. Let's make I missed a slide here. Let's make a Lego autopilot. So that's what we did. That's Lego Mindstorms in an airplane, kind of the most awkward, clumsy sort of autopilot you can imagine. There was no direct way to interface with servos, so I actually had to move the entire servo back and forth with an actuator. But it kind of almost worked. And this is what it looked like. And it's pretty crude, but we posted it on Slashshot. Those were the days, and it was like Lego Autopilot, and we were like, "That's pretty cool. Keep it up." So we decided for good measure, we put a little Lego pan tilt, gimbal on the bottom of the plane, and here's Daniel holding it, and then we decided, okay, let's do it even better. This time we'll use we have a box that could connect to radio control. Now we have all the sensors, and I sort of Googled around a little bit and learned what IMU, inertial measurement unit, was, and I Googled some more, and I was like, Kalman filter, that's some kind of sensor fusion algorithm, and it looks really complicated, and I started kind of messing around a little bit, and eventually ended up with this, which is like a real Lego unmanned aerial vehicle, UAV, which, by the way, is now in the Lego Museum in Billund, which I'm really proud about. At this point, the kids kind of lost interest. We were getting a little too technical. And by the way, it turns out that autopilots are basically cruise missile controllers. They're regulated as cruise missile controllers, like munitions, and they're export controlled. And if you let the technology get out of the United States by hosting it on the internet, you're potentially in violation of export control. And so technically, we weaponized Lego. So that was fun. I thought the fact that it was done by a 9-year-old was probably going to help me a little bit when the FBI came knocking on the door. So what I ended up doing is I said, look, I'm going to go down the rabbit hole, but I'm going to do it in public. So I set up a community called DIY Drones, and the point was to share my ignorance. So look, I know nothing about this. It's clearly way over my head in terms of technologies and the speed of advancements and sensors and everything that's inside a smartphone. By the way, is what's driving this. But by sharing my questions, other people started answering my questions, and other people shared their questions, and together we ended up basically building a really robust open source community for developing bottoms-up autopilots. we basically, this used to be super hard. Gyroscopes used to be like 10-pound lumps of metal that were classified and cost like tens of thousands of dollars. And now all of you in your pockets, in your smartphones, you've got gyros and accelerometers and magnetometers and GPS and everything you need to fly a 747 kind of badly, but everything you need is in your pocket. With the right app and the right cable, you could do that. So basically what we realized is that, thanks to the Apples and the Googles of the world, that the technology to do aerial robotics was getting super cheap, super good, super fast. And it was simply a matter of using it. And so collectively we do that. So we built an autopilot. This is our first one, which is based on Arduino. The reason we picked Arduino was not that it was the most powerful computing platform out there, but it was the most inclusive one. We realized that the key here was going to be people. It was going to be creating a way to make this easy and to bring people of all shapes and sizes and skills and experience into the process, because it's so hard, this stuff. It's analog electronics, digital electronics, software, hardware, aerodynamics, design, ground station, wireless. I mean, no single person knows all this stuff. And so we needed a platform that basically didn't make a computer science degree a prerequisite for participating. And Arduino turned out it has the best community, and that was a good choice for us. We then did our next autopilot, which is our current Arduino one, and we could see we're getting better at systems integration. It's getting smaller and better. We then worked with ETH, which is the technical university in Zurich, to do an ARM-based one, and now we're that tapped us into the hardcore academic world, and we're now kind of competing with the aerospace industry. This is real stuff, and it's just done by a community. We're going to show you an AR-Drone, a Parrot AR.Drone demo, and we love the AR-Drone. It is a beautiful platform, very, very robust, very easy to use, but it is not a drone. Drones are defined, at least as we define it, as autonomous. They're capable of autonomous flight, which is you give them GPS waypoints and they do their own thing. They take off, they land, they do their missions, they come back. Autonomy is the difference between radio control and teleoperation and proper unmanned aerial vehicles. So we love the drone's physical aspects, but it's not a drone, so we just decided to create a board to make it a proper drone. So we did this with the ETH team in Zurich. So a little bit about how these things work. You can see that these things are copters. This is a quadcopter. And the reason that we use these things is that they're mathematically really pure devices. Unlike traditional helicopters, which are mechanical, or airplanes, which again use servos, etc., these things basically just spin propellers at different speeds. And by the way, which was not possible until about 5 or 10 years ago. You have to change the speed of these propellers 100, 200, even 400 times a second. And human beings can't do this. These are inherently unstable platforms, and you need a computer on board to do the flying. So all of them are basically fly-by-wire devices. You sort of give it the overall sort of directional, push, and then it figures out what that means in terms of the rotations of the various propellers. But what you have here is two propellers that rotate one way and two that rotate the other way. And by just varying the speeds of these, you're able to do anything. You can tilt, you can go up, you can go down, you can yaw by just getting to the ones that are spinning in one direction, spinning faster, and the other spinning slower. It keeps the overall thrust the same, but gets that kind of an angular momentum going in, and it's really kind of cool math. And what's interesting about it is that you can expand to this kind of dizzying array of other configurations, and it's just tweaking the math. It's the same overall principle. You would use let's see if I have a little lasery thing here. I might have a lasery thing. I don't know. Anyway, the ones at the top was 6, called hexacopters. You would use 6 to have more lifting power, to carry a bigger propeller. 8 would have even more lifting power and also has more robust systems. So if a propeller or motor dies, it'll recover. Then these ones on the bottom with these sort of asymmetrical things are designed to give an open field of view for the cameras. So this one here, you can see the camera won't see the props if it goes forward. And this one here is also 8, but arranged in a different configuration to give the camera a better field of view. But because it's essentially solid-state devices, it's just math. It's just various lookup tables that sort of translate the dynamics into whatever that means for any particular prop. So these are kind of, this is a new thing. It really wasn't possible till we had onboard computers and these sensors and these, brushless motors and a bunch of innovations that made this sort of possible over the last 5 or 10 years. What we do with our AR.Pilot board is basically we said, well, let's just make a universal autopilot. It's a box, and you can put it in any vehicle, and it'll turn it into a autonomous, drone. We do all those copters of various sorts. We do planes, regular helicopters, and even cars, and turn them into a rover. And that's what an open community can do. It's there's nothing else out there that is attempting to do every vehicle. And what do I know about traditional helicopters? I've never flown one, but it turns out someone in the community does, and enough people start a subgroup, and they figured it out. And this notion of a kind of an autonomy box, a little box that costs like $150 that you can put in any vehicle and turn it into an autonomous vehicle, is what's really exciting, I think, about this moment. The way it works is like this. By autonomy, I mean that you have this ground station, and rather than flying it, you give it waypoints. So these are GPS waypoints, and then you script missions. You tell them what you want to do at a waypoint. Land, take off. It can look at an object. It can loiter. It can change altitude and things like that. One of the interesting functions actually is what's called a follow me function, where you can have a little box in your pocket, and this box has GPS, and let's say you're windsurfing. So you're just out there windsurfing, things are going really well, but it's the GoPro age, you really want good video of this. You just sort of push the button in the box, and your copter with GoPro camera on takes off from the beach, positions itself 30 feet behind and 30 feet above you, and it just follows you as you do your thing, right? This is the droid. This is the droid you're looking for from Star Wars, right? Personal camera bot follows you around as you do your thing, and then when the battery gets low, it just flies itself back to the beach. That's what's possible. That's just one application. By the way, the reason we use water is that there's no obstructions and no trees and such, and there are not a lot of other people around, so it's a really good application. I would not recommend the same for skiing. The way we set it up is we start with the community. The community does a lot of development, but at the end of the day, people just didn't want to have to use soldering irons and run code. They just wanted to work, and so we ended up setting up a company to do the manufacturing and the product itself. So we actually split it, and that's what kind of an open hardware model requires, is the open part, and then which is free, and you give away all that stuff. And then there's a hardware part where you manufacture, and we have factories and sell the goods, ready to fly. And that's been an interesting experience. We've been talking a lot this week about open hardware models, but we're one of those that's sort of trying to figure it out as we go. I just want to end with sort of a story about who's doing it. Again, I knew nothing about this, and as I put up DIY drones, people start teaching me stuff, and one of the first who taught me something was this guy who was flying a helicopter with a Wii controller. He'd hacked the Wii controller, put an Arduino in, and he was flying the helicopter with it. He had a video on YouTube. And I thought it was really cool, and I got in touch with him, and we talked a little bit more, and he taught me a little bit about how copters are controlled. And then we did a couple of projects together, and when it came time to create a company to make these things so that people could just buy them ready to fly, I said, let's start a company together. His name was Jordi Munoz, and I said, Jordi, tell me something about yourself, as we start a company together. Never met him. He turned out to be a 19-year-old from Tijuana. And this is how so he started in the dining room table, and went to the kitchen, then went to the basement, then went to a garage. And today, this is just one of our two factories. This one's in San Diego. There's another one, the same size in Tijuana. Today's Jordi's 26 years old. He's the CEO of a multi-million-dollar robotics company. And what I love about this is that he, I never would have found him. What are the odds that the editor of Wired would have, when he decided to start an aerial robotics company, would have ended up with a Mexican teenager? And yet, because we're community-based, the best people find us. He didn't have any of the normal skills and experience and education, but what he had was the instincts and the intelligence and the opportunity and the most extraordinary information resource in the world, the internet, to do something new. And today, I learn more from him than he learns from me. He's ramped up a production operation in a year and a half that looks like this. And I just think that's the beautiful thing about the maker movement and about community-based and open innovation, is that you end up finding the right people, even if they don't have any of the normal qualifications. So, basically, that's the current world of drones. It's military. It costs millions of dollars. There are very few. It's kind of, just like the internet or computers were back in the old days. They were owned by the military-industrial complex. And we just kind of want to take that away. We took the internet away from the military. We took computers away from the military. We all have them now. We use it ourselves. We found more uses. We've found, richer applications. And so right now we do 10,000s of drones out of our community. By the way, our community has put more drones in the air than the U.S. military has. The U.S. military has about 7,000, and we have 15 to 20,000 out there. Now ours look like this, and theirs look like that, but nevertheless, the first personal computer wasn't bigger or better than the mainframes, but they were more personal. And so the notion of personal drones, I think, could liberate this technology from military applications. We think that ultimately, as this order of magnitude calculus goes, there could be hundreds of thousands or even millions of these things out there because they get so cheap and easy, and we find such cool applications for it. So someday, yes, the sky will be dark with these things, but I suspect it will not be, Skynet becoming self-aware, but more that we find really cool applications just as we did with the web and personal computers. When you think about the first personal computer, the first, PC, where did that come from? Did that come from IBM taking the mainframe and scaling it down? Or did it come from basically makers, finding some chip that was out there for other reasons and putting it together because they could? This is the first Apple II from Jobs and Wozniak. And this is the maker movement, right? This is the Homebrew Computing Club. This is exactly where we are today, but back in 1977. And rather than doing computers, we're doing robotics. And my sense is the same way that this circuit board revolutionized the computer industry and changed the world, that ultimately this approach to robotics is going to do the same to aerospace and beyond. At this point, those are the details, and you can read more about this. I would say that there's actually a cool team out here at Maker Faire, the AeroQuad team, who you should see. They've got a great booth on the hill, and we can see these things flying, and tricopters and quadcopters, etc. You can meet them and talk to them and see the stuff. Those are kind of large, and they have spinning blades and a little slightly dangerous. So we're not going to do that in here, but we are going to do another demo. And so I want to introduce Parrot, who is going to show what's possible with the regular AR drone and some cool software.
Hi everyone. So to start, we're going to have an AR drone follow someone around wearing this very attractive little t-shirt. So we need a volunteer who wants to come up and wear this t-shirt.
Somebody young.
Why don't you pick a volunteer?
Somebody young. You do the blue shirt. There you
awesome.
go.
Can you give that to him and have him put this on while I connect all these
All right,
guys?
I'm going to put this over you. Come on up stage. All right, hold your glasses. Okay, and put the rest of the shirt on. Okay, glasses back on. So now what you're going to do is you're going to stand here.
Oh yeah, I forgot to. It's going to be different size.
And that thing is going to follow you. So you look at that. It's going to recognize you.
Do you recognize him? Oh, good. Okay.
You'll tell them what to do, yeah?
Just one check. Okay, keep looking at the robot there. Okay, so now it's taking off. It's just right now resting for a moment. And now it's found you. It's give it a second. Now it's lost you. I'm going to send it down so it finds you again.
Our demos were done with people who were taller.
Yeah. Come down. Okay. There we go. There we go. Now we'll follow you around. Oh, lost you. See, it's finding you. It's coming towards you. You can walk towards it, and it'll walk away from you. It'll fly away from you, rather. Oh, now it's confused. So I'll help it. Okay, walk backwards. Uh-oh, flying over the audience. We don't want it to do that, so we'll manually send it forward. And we want it to go down a little bit so it finds you again. There we go. Found you. Oh! And it crashed.
Thank you. Nice job.
So you want a souvenir t-shirt?
All right.
There you go.
Okay, we've got 8 or 9 minutes for questions.
I just wanted to do the one little pitch. This is not the right size. Escape, that's better. So if you're here in New York, we have a meetup group for people who are interested in flying robots. So you can check us out, meetup.flyingrobotsnyc.com. And we have a competition that is on October 20th. So if you have flying robots and you want to come out and test the abilities of your flying robots against other people with flying robots in the city, you can check that out. And then also, let's see if I can get back to the, oh, nope, that's not right. And then also I have a small little company that's not publicly launched yet, but if you want to get the source code for the robot, the controls of the robot there, you can get it from GitHub, and then you can follow us on Twitter and all of those good things. Thank you.
All right. Thank you. So, questions? Yes? Sure. Good question. How do you I'll just repeat it. How do you combat the negative press that drones have got in several wars? The answer is by showing applications that aren't military. Right now, if only the military has drones, all the applications are going to be military applications. And the reason the military has drones is because these things cost millions of dollars. These things cost hundreds of dollars. And by making drones easy, cheap, and ubiquitous, we hope to put them in the hands of regular people who will find applications that are non-military. And maybe it's going to be, following windsurfers, maybe it's going to be agriculture, maybe it's going to be wildlife management. I know, what's interesting is actually we're allowed to fly drones in the what's called the national airspace because it's a recreational exemption, whereas the biggest companies in the world aren't. And they actually have to file this long paperwork thing, get a certificate of authorization from the FAA. So my children can fly drones in the park, but Boeing can't. And I think that's great. That means that we have permission to basically demilitarize drones. And I don't know exactly what the killer app is going to be, but I do know that people out here are going to find it in the same way that we found the killer app of computers and the internet, by basically putting in the hands of regular people and letting their creativity take over. One question there, and then I'll take one over here. Yes, yeah, exactly. Oh, okay, this is a little sad. I would say that I have abused their patience. They were pretty willing, to go out with me, but robotics is hard, and it actually takes a lot of testing and programming, and the sort of work to fun ratio is pretty high. So I think it was like one too many times sitting at the field for hours with me looking at the laptop trying to debug code that they sort of had it. And at this point, I bribed them with ice cream to come to the field. And I partly do it because it's so embarrassing for a grown man to be at the field with a toy that I need a child there to be like, I'm doing it for the kids. But hope springs eternal, and I think you will see a demo, another quadcopter demo from Stephen Wolfram in the next talk, or maybe the talk after that one.
The next one.
Yeah, he's with a 13-year-old, and kids are into this stuff. My kids may be a little burned out on it. Oh, over here, yeah. Yeah, oh, so the question was about flying in the national airspace. So the rules are this. If you're flying recreationally, you have to fly under 400 feet. So manned aircraft are above 1,000, then there's a 600-foot buffer, then there's 400 feet. So we have to stay below 400 feet. You have to stay within visual line of sight, unassisted visual line of sight, which is basically, sort of a half mile. You need to stay away from people, away from built-up areas, away from airports and things like that. So pretty clear guidelines on this. But if you follow that, and there's a lot of places where you can do that, you're fine. Yes, right here. Yeah, this is the question about civilians weaponizing these things. I think it's like computers or any other technology. It is, yes, you're right. When you put things out there, people could use them for ill. By and large, we've had a radio control airplane since the 50s. So the ability to sort of fly a remote aircraft, has been around forever. Typically, people are not using it for they're not using that for that function. It turns out it's like a relatively hard way to get bad things around. But I think it's possible, and probably even likely, that someday somebody will do something bad. And what we do to avoid this is we really preach, safety and responsibility on the site, and we encourage everything to be done in public. And thirdly, and this is important, we brief the relevant agencies all the time. So we're always, talking to the agencies, all of them, including the FBI, and we've invited them into the community. They participate. We've told the community, we've invited the FBI in to look, to follow what's going on. And we feel like it's our job to inform the regulators and law enforcement what's possible, and it's their job to decide how to enforce. So I think, basically by doing things in public, we're increasing the chance that bad people will be spotted earlier, not just by the regulators and then law enforcement, but by the community themselves. And we are hardcore. When someone starts talking about, we don't allow discussion of weaponization or military use or anything dangerous, and if somebody starts getting a little loopy and starting talking about this stuff, we just dive on them and make clear that this is not okay. Yeah, over here.
Are you curating, or is anyone curating a collection of things that aren't bad?
A collection of bad stuff?
No. Curating a collection of good things. It was
Oh.
very nice to hear the example about surfing. I was like, because when you say drone to me, I can't imagine anything.
Yeah.
What I term to do.
That, the answer is we, yes, we're constantly, we have basically DIY Drones is built around sort of a social network, but it's got a blog channel. And on a daily basis, maybe not daily, but several times a week, we bring out examples of cool things that people are doing with drones that aren't military. So it's like, some people are using them for, I mentioned wildlife management. What drones are good for is jobs that are dull, dirty, and dangerous. But actually dull was the most important one. Just keeping a camera over a herd of elephants all the time, 24/7. It's a really dull job for a person. It's a great job for a drone. Crane nesting, for example. Just spotting where the crane nests are, but you want to do so really quietly so you don't disturb them. Turns out that small aircraft are really quiet, and they're good at that. Agriculture is going to be huge for this. Farmers really want daily overhead multispectral imaging of their crops to use water more efficiently, etc. And those are just some three off the top of my head. But the answer is we're constantly telling a story. But you're right. We probably should have 10 great civilian things that people do with drones, and just put that together as a document. Thank you. Do we have time for one more? One more question. You, sir, in the back of the hat. Yes. So if you have an AR drone and you get the replacement board right now, I wouldn't recommend you get it right now, because a little programming is required. Wait 6 weeks and they'll be pre-programmed, ready to go. I mean, in general, the way our stuff works is that no programming or assembly is required.
I should point out that this is actually using the stock AR drone.
Right.
And the software that you can get on that GitHub will make it do everything that...
Thank you. Good point. Yeah, the stock AR drone, which costs like $300, is great. It requires no programming to work out of that box with an iPhone or an iPad, an Android interface. If you then want to replace the board with something that allows autonomy, at the moment it requires a little bit of programming. Just for this one, give us 6 weeks and it won't. But for the other stuff that we do, the Pilot, the copter, plane, etc., that kind of just works out of the box. You just kind of, you download some desktop software and you press a button, and no programming is required. But more to the point, if you want to program, you can. You don't have to hack it, but you can. All right, I think that's all we have time for. Thank you very much.